Hi, in this video we're going to work out some problems, stoichiometry problems, and this is the main strategy that we're going to use to solve any of these kind of problems. The first thing is look at your chemical equation, make sure that your equation is balanced. That's the very first thing. That will give you the right stoichiometric factors, the stoichiometric ratios for different pairs. For example, reactant to reactant, a product to a reactant, between two products, etc. Then because we're looking at these stoichiometric ratios, the stoichiometric coefficients, we always have to go to moles, always. No matter if we start with mass or we start with for example, a concentration, we always have to find a way to go to the moles and then use the stoichiometric factor to convert between moles of a substance to the moles of the other substance and go from there to finally solve the problem, whether we're asked a number of moles of a product, for example, or the mass of a different component, okay? But that's the main strategy. So let's look at the first problem. The first problem is related to photosynthesis, and it's asking us basically looking at, given a certain amount of grams of CO2 that a plant takes in during a week, how many grams of glucose will be expected to be produced by the plant. Okay, so the main problem again, make sure first that the reaction is balanced. If you go back and look at the problem, the reaction that it's given here clearly is not balanced. So that is the very first thing that we have to check, that the reaction is balanced. Now we are balancing this equation. We have to look at the stoichiometric ratios between the two components that we're interested in this case, according to the problem, CO2 and glucose. So the stoichiometric ratio is going to be between these moles, 6 moles of CO2, and the moles of glucose, that in this case is 1. So the stoichiometric ratio is going to be 6 to 1 or 1 to 6. According to the dimension analysis, we're going to see that it's always going to be the one that we want to find divided by the one that it's given. So that's going to be our stoichiometric factor. The trail of steps that we have to do, first, if you're first practicing these kind of problems, I strongly suggest you to do this step at a time, is first go to moles. We're starting with a certain amount in mass of CO2, so we have to find the corresponding number of moles of CO2 because we're going to use the stoichiometric coefficients, the stoichiometric ratios, the stoichiometric factor. Okay, that stoichiometry is relating moles. It's a mole ratio, so we always have to go back to moles. Once we calculate the number of moles, we can determine the number of moles produced, the moles of glucose produced, using that stoichiometric ratio. So we said in this case it was 6 moles of CO2 with respect to 1 mole of glucose, and we ended up having this stoichiometric relationship here as our stoichiometric factor. Okay, remember, it's always going to be this relationship. The one on top is going to be the one that we want to find out, and the one in the bottom is the one that we are given, because that's what we want to cancel. We want to cancel the moles of the compound that it's being given to make the moles of the one that we're being asked to survive. So now that we know the number of moles of the glucose, we can just get the mass of glucose by using the molar mass of that particular substance. So we multiplied moles by the molecular mass of that, and then we end up finding the total mass of glucose.